2.92 gram sample of potassium chloride, potassium chlorate mixture is decomposed by heating, and it produces 89.8 cubic centimeters of oxygen. This has been measured at 21.8 degrees Celsius and a pressure of 727 millimeters of mercury. What is the mass percent of potassium chlorate in the mixture? Our hint is that the potassium chlorate is unchanged. We go ahead and we take a look at this. We have a 2.92 gram sample of the mixture. We have the volume of oxygen and the temperature and pressure at which that oxygen was achieved. We also have the balanced chemical equation. There are 2 potassium chlorates for every 3 oxygens. We're going to go ahead and start with our 2.92 gram sample of the mixture and work towards our N value for oxygen. After that, we can go ahead and put oxygen into the ideal gas law, PV equals nRT. I'm not a fan of having R memorized. I'd rather customize it. But writing it this way allows me to focus on the volume or focus on the moles. Moles equals pressure times volume divided by RT. We're going to start with our 89.8 cubic centimeters of oxygen. This is our V. We'll be able to also put in our pressure as well as our temperature. After that, we'll be able to customize our R value. The R value will allow us to get to N. Remember, with your temperature, you're going to have to convert to Kelvin, so if it's in Celsius, add 273. Our customized R value will allow us to cancel out cubic centimeters and millimeters of mercury and Kelvin. Now, since the R value is typically listed as 22.4 liters for every 1 mole at STP, we're going to have to convert liters and cubic centimeters. This allows us to cancel out our millimeters of mercury, cancel out our Kelvin, and again, we will have to worry about converting cubic centimeters and liters. A cubic centimeter is 1 milliliter. There are 1,000 milliliters in every 1 liter, and so we're going to go ahead and get rid of liters and cubic centimeters by stating that there are 1,000 cubic centimeters for every 1 liter. Once this is done, units will cancel so that only moles of oxygen remain. After that, we can use our stoichiometric relationship to say that for every 3 moles of oxygen, there are 2 moles of potassium chlorate that are consumed. Once we're into moles of potassium chlorate, we can go ahead and use the molar mass of potassium chlorate to determine how many grams of potassium chlorate are in this mixture. After that, we'll be able to do that mass divided by the whole, the 2.92 gram sample, times 100%. When we cancel out all of our units, we'll notice that grams goes away, but potassium chlorate stays. The label sample goes away, but the percent sign stays. This allows us to see pretty easily the percent potassium chlorate. We solve and find that it's 9.94% potassium chlorate.